Okay, in this video, I'm going to take you through recoding a few more types of variables and how to create some not frequency distributions, but histograms and bar charts to uh, show the distribution of your variables and also how to calculate a few different descriptive statistics. Ugh, I cannot speak at the moment. Okay, so you might notice as you see the scripts that I have out there for you that I'm going to start setting them up like this, where there's different sections. So typically I like to, kind of label like this top section. I throw all my packages in there that I think I might need. And then I have a section for data sets that I might need to import, then a section for data cleaning. This just kind of keeps your script well organized once you start doing data analysis. So we're going to run these two lines of code and open these two packages that we've been using. Rio, so that we can import our data set, and QDAP in case we need to do any frequency distributions. And then we're going to import the data file that we exported at the end of the Tidyverse video. So it should be like your last name with an _2, or however you indicated to yourself that it was the second, not the original data set, but a new one. And we should be up to 177 variables at this point. Yeah, so if you've not already noticed, when you type different functions, it's going to prompt you with some options for possibilities after you hit the third character. If you just hit enter, it's going to give you your parentheses, which is super handy because, as I said the other day in class, big driver of errors is missing one of those parentheses. So when you click on the suggested function, this is what happens. And yeah, so that's that. So we're going to look at some variables for policy preferences in the next assignment, assignment 2. I know you're probably all still working on assignment 1, which is fine. But I wanted to get this out there for whoever's ready to move on. So we ask you to recode the variables so that the lower values represent the liberal viewpoint and the upper values represent the conservative viewpoint. Some of the variables will already look like this, and some you'll have to flip. So if we run the table for this variable, which is, I forget already, defense spending. Yeah, policy preferences on defense spending. We see we've got 1 through 7, and then there's some 99s and some -9s. We can assume this means refused because we kind of learned that in our other variables we were looking at. But what is this 99 business? So I have pulled up in the code book. You see that this is the 7-point defense spending scale. Where would you place yourself on the scale, or haven't you thought about this much? -9 is refused. -8 is don't know. Oh, also, some of you might see some -8s. I don't have any in my data, so I think I might not have written the formula to accommodate that, or maybe I did. I don't know. We'll see in a minute. Anyways, so 99 represents haven't thought about this much, and 1 through 7 is just this 1 greatly decrease. The person thinks we should greatly decrease defense spending. So that's the liberal point of view, which that's what we want. We want the liberal point of view having the lower values. All the way up to 7, which is greatly increase defense spending, which is where we want it. We want the conservative end to be the higher end. But what are we going to do with this 99? So we'll pop back over here to R. Did I talk about all of this? Yes. Okay. So I mean, technically this 99, we could toss it out. So if defense spending is going to be our dependent variable, we don't want to impute any values. So we would actually recode this as NA, or missing value in that case. But say we're just going to use this as independent variable, then we want to save as many cases as possible because like we talked about in class, the more observations we throw out, the less representative our sample becomes. So here, and I did include the negative eights there, even though I don't have any. Here we're going to create this new variable called defense spending. And our first logical test is if the original variable equals -9, or that's what this vertical line means. If the original variable is -8, we want it to be NA. If these logical tests are both false, then we move on to a new logical test, which is if that original variable is 99, we want it to be 4. And the reason for this is because 4 is in the middle. So if you think about this, like if someone answers, well, I haven't thought about it that much, then they don't really hold the super liberal viewpoint, but they don't hold the super conservative viewpoint either. We can infer or impute that they're in the middle. Again, that's dangerous if this is a dependent variable, but if we're using it as an independent variable, we can get away with just sticking it in the middle here. So if we run that code, see, we're up to 178 variables, and run tables on both the new and the old variables to make sure they match. You see our -9 has disappeared. The 99s have disappeared. Category 4 is pretty large now. It's the 249 plus the 163, or in your case, these are going to be, again, slightly different because your data is different. But the other variables are all the same. So 1 is still 1, 2 is still 2, 3 is still 3, 5 is still 5, 6 is still 6, 7 is still 7, because we already were going the same direction, or in the direction that we wanted the data to be. So next we can move on to the variable for death penalty. If we want to look at that data, we see we have 4 categories. And to get an idea of what they mean, we can go over to the code book and look it up. So 1 means we favor strongly, 2 favor not strongly, 3 oppose not strongly, 4 oppose strongly. So in this case, the viewpoints are flipped. We want the liberal viewpoint opposing the death penalty to have a lower value, and the conservative viewpoint, which favors the death penalty, to have a higher value. So this time we're going to flip them. But first I do an example of how we would recode this as a nominal variable. Because should we be recoding a variable with only 4 categories as numeric interval variable, or should it be nominal? And that's a sticky question. It's going to depend on your data and what exactly you're doing with it. For our purposes in this class, we'll ultimately leave all of these policy preferences as numeric, but there's definitely good arguments for keeping it as a categorical variable. And to do that, you would run this code like this. This is very similar to codes or to functions that we've already done, so I'm not going to go through this line by line. But if we run it now, we're up to 179 variables. Notice that now when we run the table, it puts us in alphabetical order. Remember that it lists everything out in alphabetical order, but in this case we can say that there's some logical order to the categories. Census region, not so much, but in this case there's definitely a logical order to the categories. So there is a way to then put these in order, and that is by running this code here. So what this says is take the variable we just created called death penalty and turn it from a character into a factor variable. This is the original variable, that's the input. And then this levels argument tells what the different levels should be. So you're going to want to put this in order how you want it. So oppose strongly, oppose not strongly, favor not strongly, favor strongly. And then this final argument, order equals true. So if you run this code, then you should see that now it lists the categories in the order that we designated. And if we run these two tables together, we can see that it's flipped these, but everything matches, so everything's recoded correctly. And we just got rid of this -2, which I don't remember what that was, but it's missing data. However, like I said, we're actually going to keep all of our policy preference variables as interval or numeric variables to make things easier later when we're running regressions and stuff like that. But note, in this instance, we did have to flip the direction of the scale to get it to run from liberal to conservative. So rather than this up here where we fed it all of this information but had these as our new values that we wanted to recode to, we just flip the order of the numbers and we'll get ultimately what we want. Okay, so summary statistics. In base R, the function HIST will give you a basic visualization of a numeric variables distribution. So it's just hist and then within the parentheses the name of the variable, and it'll give you this really ugly, clunky looking graph over here in your quadrant. Wherever your plots tab is, it could be in one of your other quadrants, however you have yours set up. Mine's up here. You can do some customization to the basic hist function in base R. You can rename the x-axis with this xlab equals argument, and then you can rename the y-axis in a similar way. You can also set the limits of the y and the x-axis. You can change the title, and you can add some color if you want to. So if we run this, looks just a little bit better than it did. And then more customization. Here we change the where you can reset where you want the breaks on the x-axis. So if you run this, now that looks really weird. But that just gives you some idea of some of the customization that can be done with the hist function in base R. If you try to put a non-numeric variable into the hist function, you'll get an error. That's going to tell you that the x or the whatever you're feeding that function needs to be numeric. So for nominal and ordinary variables of class character or factor, class character or factor, you can use the bar plot function instead. But the input is a little different. You can't just stick the variable name in there. You actually have to stick a table object in there. So, because if you try to do this, you're just going to get another error. But if you create an object out of a table, so now you have the census region object over here that is a table of the frequencies of the census region variable. and you feed that census region object into the bar plot function, then you're going to get this, which is very similar to the histogram, but you see we have like these discrete categories instead of like ones that run together. You could also just feed this directly into the bar plot function. You don't have to create an object first. It's going to do the same thing. Didn't even see a difference because it was just put the same thing up there. And then you can customize this similar to the hist function. You can add X and Y labels. You can change the numbers on the axes to have a min and a max, and then you can change the color with the COL argument. And if you have long category labels, this is gonna look stupid because they're not really that long, but you can actually turn them sideways with this last argument, LAS equals 2. Makes your labels turn vertically here. So the base R graphics generally are very clunky, difficult to customize, but this package ggplot2 offers a lot more flexibility, a lot of better looking graphs in general. So you're going to want to uncomment this line of code and run this install packages if you didn't already get a notice when you open the script that asked you to install it up here, like some of you get. And then you'll want to run the code to open the package. And we're going to get rid of this object here. And then, so this is how the function ggplot is set up. This is kind of like the structure of the ggplot. So you're going to have ggplot is your function. Data is going to be whatever you're feeding it. That's going to be your variable usually, or something like that. And then this mapping equals AES. These are the aesthetics that you're giving to the graph. And then this plus sign and geometric object. Now the geometric object is the type of plot that you want to show. So geom point, geom bar, geom line, geom histogram are some common ones, and we'll kind of show you what those look like as we move along here. So for numeric variables we're going to use geom histogram. So ggplot is our function. My data is the data frame that we're using, and then AES x equals age. So age is what we want along the x-axis. And then geom histogram is the geometric object that we're creating. And within that, we're going to have these couple arguments here. Bin width is what type is the width of each of these, how wide we want each bin. And then fill is the color. If you just Google ggplot colors, there's a zillion colors that you could use out there. We'll run that. And now I know I said that ggplot looks cooler than base R graphs, but the basic ggplot is really not that pretty. You have to do some things to customize it, adding additional pluses and additional lines to kind of make it a little bit more attractive. So the first thing we're going to do is there's tons of themes out there. Again, you can Google to find what the various themes are and what they look like. But if we run that, notice that the theme BW stands for black white. It just is talking about like this. It's not talking about the bins. It's talking about like the outside of the graph. We can add labels. So we've got this original bit of code, and then we added this theme, and now we've also added this labs, and then in parentheses we give it the X label, what we want it to change the X label to, X equals, and then our label needs to be in quotes. Y label, maybe we don't want a label because like clearly it's not just numbers or counts. So if you don't want a label at all, you put null. Otherwise you could, say count in quotes here. And then title, we can give the graph a title. And then what am I doing here? And then this little addition here is going to angle or justify the axis ticks. So we've got the census region distributions. We've got their labels kind of like off at the diagonal. Definitely looks much cleaner now than it did in anything that we've run so far, basically. Oh, also, by the way, this is because this is nominal variable, we use geom bar here instead of up here we were using geom histogram for the continuous variable. Okay, now we are going to recode ideology because we're going to graph that also, because I'm going to show you how to label the ticks when they're actually numbers. So we're going to take a look at the ideology variable. We've got some -9s. We've got some 99s. Let's take a look and see what that is to make sure. So just like in the last variable we were looking at, 99 is haven't thought about this much. So this is a good example of when it's most likely okay to recode this in the middle of the scale. The other variable, since it was the defense spending variable, a lot of times you're probably I would say a lot of times that might be a dependent variable, or there's a good chance that would be a dependent variable. So you're going to be less likely to want to recode those 99s as 4. But ideology is most often, I would say, used as a predictor, not a dependent variable. So you can feel pretty comfortable with recoding these 99s as 4, which is what this line of code does. So if you run this code here and then check and make sure everything recoded correctly, see that everything matches. 7. Oh, also notice that it was already going in the correct direction. We had the liberal values at the bottom and the conservative values at the top. So we didn't need to flip anything. We just needed to set the missing values to -9 and these 99s to the middle of the scale. Other than that, we just wanted to retain everything as it was. So you see everything like matches up. These 179 got added to the 248. The 3 dropped off, and everything else is what it should be. So now we're going to do a histogram of ideology. Because it is a numeric variable, technically, we can use histogram. We're gonna make the x-axis. We're gonna label it ideology. We're gonna remove the label from the y-axis. We're going to give it a title. And then this argument here is going to replace, because remember we left it as numeric, it's going to replace the values 1, 2, 3, 4, 5, 6, and 7 with actual descriptive labels for our graphs. So it's functionally, we want them to stay numeric in our data, because when we run a regression, we want the continuous variable. It's just more useful for us. But if we produce a visualization of the distribution of that variable, we want to actually know what those numbers mean. So that's what this bit of code here does. And then I also included this little bit of code to make it diagonal, because you'll see in this case, it actually, these are pretty long. And there's more of them, so they're closer together. So it's actually very useful to have them like ticked sideways like that. Okay, so the last little bit here is going to be just all of the functions to compute different measures of variables. So to compute measures of central tendency, we've got the mean and the median. For both of these, it's just mean and median, and then the name of the variable in parentheses behind it. But we also need to add this na.rm equals true to tell R to ignore the missing values. Otherwise, you're just going to get an error. So if you run both of these, you'll see that the mean age is 51.72 years. The median age is 53. And then to compute measures of dispersion, so for numeric data, we've got SD for standard deviation. Min finds the minimum value in a variable. Max finds the max. Range gives you the min and the max in the same function. IQR finds the interquartile range, so the distance between 25% and 75%. Quantile, the quantile function, you can either feed it this 0.25 argument or the 0.75 argument after the variable and before the na.rm equals true. 0.25 returns the lower quartile and 0.75 returns the upper quartile. And then if you just use the summary function and then feed it a variable, it's going to give you all of that stuff, not all of it, but a lot of it at once, which is useful for getting an idea of what the distribution looks like, sort of, but it's less useful if you're trying to use that calculation within some other analysis. So these are all important individually for reasons of basically computation. Like if you need to calculate something later on when you're doing more difficult stuff, these basic functions can come in very useful. So to visualize this, we can use the box plot function. So this will tell us the mean, and I think this is the interquartile range, and the min and the max. We can also add arguments to this to customize if we want to. So here we've set the y limit to 0 and 100 and changed the color, gave it a title. So these are the functions to find the central tendency in a continuous variable, the mean and the median, but there is no function for finding the mode of a categorical data. You're just going to have to determine this from your bar chart. So whichever of your bars is highest, that's your mode. You can run a summary on a categorical variable, but it's not very informative. It just says mode, but I mean it's not really just giving you any information. And then this down here is just some a few different things in about the text. If you're caught up on the reading, section 3.5.4.2 talks about formatting dates. That's useful information. Not so much for this class, but it could be in the future. I don't use dates hardly ever. Once or twice I've had to use them, and I had to kind of Google my way through that both times. Also, you'll note that the text uses rCommander, which is we're not using. So anytime it talks about rCommander, you can skip that part of the reading. I think rCommander is more of a, what do they call them, a GUI interface, I forget what the initials stand for, but it's point and click, and we're not gonna do that. We're writing code. Also, even though we're using the Rio package to import data from other programs, this section here is super useful because it has some tips on what might be wrong if you're getting errors when you bring over your data. And then these sections, 3.9.2 and 3.9.4, are on subsetting and reshaping data, and also very useful. But because we crunch quite a bit into this class, I don't really get into subsetting and reshaping at all, or I didn't last year. This is you guys are a lot smaller than the class last year, so we may get through more stuff potentially. So as of right now, I don't have plans to go over this, but that might change in the future. But that's it for week 2.